Okay, so now we're on from scatter plots to the second part, which is correlation. So again, we talked about direction, form, strength of a relationship and some unusual features. One of the things that help describe that is a number we call correlation, or R. So that describes both the strength and direction of the association. So it's a strength and direction. This only works for linear relationships. So if you're doing something that's curved, you don't want to use R. It's only for strength for linear. So it's called linear strength. So it's always a number between -1 and 1. The closer it is to -1 or 1, the stronger it is. So 0 is very weak. 0 is the weakest you can get, actually. If it's positive or greater than 0, then it's a positive correlation. And if it's a negative correlation, going down there, that's going to be a negative R value here. So they only occur in perfect. It can be 1 or -1. It's possible if it's a perfect correlation. Everything's right on the line, if that's the case. But the closer it is to 1 or -1, the stronger it is. Closer to 0, the weaker it is. So here's just some different R values. You can see in the top left, that data has no correlation at all. It doesn't seem like it's not positive or negative. It's just 0. It's very weak. You can barely see that it's negative on the next correlation. That's R equals -0.3. So it's weak and negative would be the form and direction there. The next one is positive. You can tell it's going up and to the right. Maybe 0.5 it looks like is the correlation. So that's really not that strong. It's halfway between weak and strong there. It's kind of moderate. -0.7. So the next one is getting a little stronger. That's moderately strong, but it's negative because it's going in the negative direction there. But the R value is also negative. Here the R value is positive in the bottom middle there. And it's getting a little stronger. You could almost say strong, not quite. Maybe it's still just moderately strong. And then the last one is strong. It's pretty good correlation there, and it's very close to -1, so it's quite strong, actually. I would write down these 3 or 4 things here. Correlation does not imply causation. We'll see that over and over again. It doesn't measure the form. It just, how strong it is, so to speak, and the direction. So only describes linear and is not a resistant measure. So if you have one point that's kind of wayward, it's going to have a huge effect on the correlation. So one outlier type point or unusual point will do that. Okay, so how do you calculate it? You don't need to know that. It's not important for us. So correlation requires that both variables will be quantitative. That's true. Again, explanatory is the X variable there. Response is the Y variable on a graph, and it measures the strength there. It makes no distinction. So you can actually flip-flop X and Y, and you still get the same correlation R value. Units of measure, don't change it. Change it from inches to centimeters or whatever. Just not going to change it. It doesn't have a unit of measure. It's just a number. It's a standardized number, essentially. So let's look at just a couple problems. So here we have one. We have some data there. I would describe that data as strong, positive, linear, with no unusual points there, it looks to me. And it's talking about the relationship between the arcade revenue and the number of computer science doctorates awarded. So will playing lots of video games at arcade make you likely to get a science doctorate? Explain your answer. Okay, so there is a strong linear positive correlation there. So you might think, oh, that's going to do that. But it's kind of implying causation here. Isn't it the way the question is worded? So actually we might predict that could happen, but we're not going to say one causes the other to happen. So even though there's a strong correlation, causation should not be inferred. We cannot go there. We can predict, but we can't make a causation there. So this one, the scatter plot between arm span and height, I would expect a positive correlation, and it is. Moderately strong at least there. It's positive for sure, linear. And the correlation is 0.902, which confirms it is positive and somewhat strong there. 0.9 is close to 1, so that's pretty strong. Why is it incorrect to say that correlation is 0.902 centimeters? You would just say 0.902. There is no unit of measure for correlation. What would happen to the correlation if height was measured in inches? So that kind of stuff, changing the data by it doesn't change the correlation at all. What happened if correlation of height was used as explanatory variable and arm span was used as response? So the correlation would stay the same. I don't think it would make as much sense. I think arm span seems better to predict the height, but it would be height predicting arm span, which I guess you could do if you wanted to. But it wouldn't change the correlation at all. Perfect. That's the lesson for today.